All right, so we have already talked about simplifying square roots. So let's just do one together real quick. Square root of 75. 75 is not a perfect square, but I like to, I'll just leave my list over here. 1, 2, 3, 16, 25, 36, 49, 64, 81, 100, 121, 144. Okay, so I remember that if I want to simplify this square root, I want to find the largest perfect square that divides into that evenly. So if I'm looking in this list, the largest one that divides in, of course, is 25. So I have 25 times 3 gets me back to 75. Square root of 25 is 5, and then I leave the square root of 3, right? So basically what I'm trying to do with everything is take it and find a perfect square that divides in evenly. I essentially want to do the same thing with variables, but it's weird, okay? So let's try this. What do you get when you multiply x times x? X squared, right? Same thing like 3 times 3 equals 9, right? Right? 3 times 3 is 9. So that's why the square root of 9 is 3. So, using that logic, what do you suppose the square root of x squared is? X, right? Because x times x gets me x squared. So the square root of x squared should just be x. You follow me? Okay, so let's try this. What is x squared times x squared? X to the 4th, right? And I know this is a bad example because 2 times 2 is 4 and 2 plus 2 is 4. But what are you really doing with the exponents here? You're adding them. So 2 plus 2 gets me 4. So let's use that same logic. If I wanted the square root of x to the 4th, it's got to be x squared. So now here's where it's going to feel wrong, but it's not. What is x to the 3rd times x to the 3rd? X to the 6th, right? So what's the square root of x to the 6th? Yes, x to the 3rd. And I know it feels wrong and weird because 6 itself, 6 is a number, it's not a perfect square. 6 is not over here in this list. However, x to the 6th is a perfect square. Does that make sense? Let's do another one. So if I had x to the, let's just jump to 5th. X to the 5th times x to the 5th would get me x to the 10th. So the square root of x to the 10th has got to be x to the 5th, right? So, are you seeing a pattern maybe? What if I did like x to the, I don't know, 11th times x to the 11th would get me x to the 22nd. So the square root of x to the 22nd must be x to the 11th. Are you noticing anything about these numbers and these numbers? I wish this had a highlighter tool. Oh man, all I have is different colors. What do you notice about these numbers? It's just half. So to take a square root of a variable raised to an exponent, all you have to do is take half of its exponent. Does that make sense? So, in other words, if I asked you, okay, well, what is the square root of x to the 84th? You know right away it's just x to the 42nd. It's just half of it, right? That's it. So, don't get confused on something like this. X to the 100th. Square root of that would be x to the 50th. I know that 100 is a perfect square and the square root of 100 is 10. That's not what this means at all. You always just take half of the exponent. If 100 is an exponent, right, it's different than just the number 100. So our golden rule that we need to remember is the square root of any variable raised to an even exponent is just the variable raised to 1/2 that value. The exponent's value. So let's try and put this all together, because we're not going to have just numbers and just variables. We're going to mix them. So say we looked at simplifying the square root of, I don't know, how about 72x to the 20th. Okay, so if I'm going to try and simplify this, I'm actually going to, even though I have a coefficient and a variable here, I'm actually going to break them apart and deal with them separately. So I'm going to first split this into the square root of 72 times the square root of x to the 20th. So now let's handle the square root of 72 just like we always do, just like you did last night. So in my list up here, what is the largest perfect square that will divide into 72? 36. So I'm going to take this and I'm going to split this one up into the square root of 36 times the square root of 2. So that just gets me 6 times the square root of 2. Okay? Now let's handle this square root of x to the 20th. What is the square root of x to the 20th? X to the 10th. So I'm just going to bring that down. Now, when you go to write your final answer, this is all multiplication. You're just multiplying all these numbers together. So, what you want to do, though, is you want to multiply any numbers together that are, like, not under radicals. So if I had any of those, I'd multiply them together, put them out in front. And you want your variables next, and then at the very end, anything that's still in the square root. So to write this answer the right way, I'd write it as 6x to the 10th, and then put the root 2 on the end. Okay, so first our normal numbers, then your variables in alphabetical order if you have more than one, and then your radicals go on the end. Okay, let's try another one. Say we did square root of, how about 54x to the 18th, y to the 34th. Okay, we got somewhere? So I would again start by breaking it up. I have square root of 54. I'm also going to deal with the square root of x to the 18th, and then I would have the y to the 34th. So I just break it up into 3 little mini problems, and I handle each one separately. And at the end, I just multiply everything together. Okay? So 54, what's the largest perfect square that goes into 54 in this list? Someone said it, I think. 9, right? 9 times 6. So that gets me 3 root 6 from this. Square root of x to the 18th. X to the 9th. Y to the 34th would be y to the 17th. So then I'm just going to write my answer. 3x to the 9th, y to the 17th, and then the square root of 6. Yeah.
It was like y to the 30.
Okay. So what happens when that thing's odd? Because now it's not quite as nice anymore. So I'm actually going to go on to page 2. Oh, this thing is so cool. All right, so what if the exponent is odd? All right, so let's start off with one that's not, let's not go too big yet. How about, let's go with x to the 11th. Just like when I have a number in there that's not a perfect square, right? When we first started this lesson, we started with x to the 75th. Or I'm sorry, square root of 75th. That's not a perfect square itself, but I broke it up into the largest perfect square that does divide in times whatever else I need to get back to 75. It's the same idea, but it's weird, okay? Can I divide x to the 11th by, oh gosh. Well, let's rewind. Let me ask you this question. What is x to the 10th times x to the 1st? Isn't that x to the 11th? So can I say that these two things are factors of x to the 11th? Right? Factors are just two numbers that I multiply together to get the bigger number. Like factors of 10 are 2 and 5, because 2 times 5 gets me to 10. Factors of x to the 11th include x to the 10th and x to the 1st. Well, isn't this a perfect square? X to the 10th? Yeah. So that's basically what I'm going to do. No, 10's not a perfect square, but x to the 10th is. Any variable raised to an even exponent is a perfect square. Yeah.
But couldn't you do like x to the 6 times x to the 5?
So you could, but the problem is that's not the biggest perfect square, right? So you could do that, but then you'd have to break up x to the 5th. You know what I mean? So you always want to pick the largest perfect square that goes into a number. So in this case, it's just going to be x to the 10th and x to the 1st. So for square roots, it's always just one less than whatever your odd exponent is. It will always be your biggest one. So watch how this breaks down now. You know what the square root of x to the 10th is. It's just x to the 5th. This doesn't simplify. You just leave it. So just like when I did the square root of right here, just when I did the square root of 75, my perfect square comes out nice, but then I left the square root of 3 because it didn't, I can't simplify that any further. Same thing's going on here. I can't simplify the square root of x any further. So that is my answer. So your steps are always basically going to be the same thing. Say I wanted the square root of x to the 33rd, right? So to simplify this, you're going to break it up into, you always go one less. So you go down to 32. And then this one would just be x to the 1st. Now, what's the square root of x to the 32? X to the 16. And then this one just stays. If you remember to do it, yeah.
If it was x to the 2nd, and then you factor that, no, like about, like the one where it says 32x to the 1st, if it was x to the 2nd, would you, and then you factor that out, would you add the x to the 1st to the x to the 16th?
I don't think I know what you're asking.
If that was, if that other one next to it was x to the 2nd.
Oh, so that would never be, because if you split it up and it was 32 and 2, that means that this would have been 34 and it would have just been a 17 from the beginning. let's try another one. So say you had square root of x to the, 51st. So I'm like, oh, that's an odd exponent, so I'm just going to split it up into what and what? Exactly. I just go one less, x to the 50th and x to the 1st. And then the square root of x to the 50th is x to the 25th. And then I just leave the square root of x, just like that. Does this kind of make sense? Okay. One other thing that I just need to mention is that we are assuming that all of our variables represent positive numbers, because if x ends up being negative, there's some weird things that can happen in there. You'll deal with that more in Algebra 2, but we are assuming all of our exponents, or I'm sorry, our variables are representing positive numbers. Okay. So let's try putting these together again. Say I had the square root of 16 x to the, how about just third, y to the 8th. All right, so if you're faced with anything like this, first step, I would recommend just break it up into the 3 smaller pieces, or however many pieces you need. Do the 16 by itself, do the x to the 3rd by itself, and do the y to the 8th by itself. So give this one a shot. Let's see what we come up with. Okay, we got something? So, square root of 16 is just 4. So that was easy enough. Okay, now, square root of x to the 3rd. That's not a perfect square because it's an odd number. So, I got to split it up. X to the 2nd and x to the 1st. What is the square root of x to the 2nd? Just x. I'm just going to bring this 4 down a little bit further. So that's just an x. And then this, it just stays. There's nothing else I can do with it. And then the square root of y to the 8th would be, there you go, y to the 4th. So then to write this final answer properly, just put the radical at the end. So 4x y to the 4th, and then square root of x on the end. How'd you do? Okay-ish? It's a little weird to get used to. I get it. Especially because it's really even odd that you care about. You don't really care about what the number is. It doesn't have to be a perfect square. And when you see perfect squares, I know it's tempting to be like when I ask you what the square root of x to the 25th is. It's so tempting to think that there's a 5 involved, but there's really not. You just gotta, this is one you'd have to split, right? X to the 24. X to the 1, so you actually get x to the 12th times square root of x. So when it's an exponent, perfect squares kind of go out the window. It's just even odd. That's important. One more for you to try, and then we'll do some on the board maybe? Okay. Let's just do one. You might have a number out in front too. So let's say you had something like 6 square root of, let's just do 20, x to the 15th. Try that. Okay, we got an answer? So, what happens with this 6 out in front? Nothing really. It's just gonna be part of your answer, right? You're just gonna multiply it at the end with all the other stuff. So for now, I'll just keep bringing the 6 down, doesn't really do anything. So 6 is there. 20 is not a perfect square, but I can break it up into, yeah, square root of 4 times square root of 5. So that's going to get me 6, that's a 2, and then just bring down that square root of 5. X to the 15th, not a perfect square, but I split it up into x to the 14th and x to the 1st. So this is now x to the 7th, and then that just stays. So now to write this answer, I'm going to multiply all my numbers not in a square root together, so I would just get 12. Then I have the x to the 7th, and then since I have both of these that are both under a square root, you just put one square root and they both go underneath it. That's it. Oh, sorry. So, final answers should only ever have one radical in them. You're not going to write it as square root of 5 times square root of x. You're going to put them together under one square root. Okay? And that's it. So, just double check that you only have one radical. It should always be at the end of your answer. Your coefficient should be out in front. And then just any variables that you might have, just make sure they're in alphabetical order. And that's it. Okay, so let's try some of these.